So a few weeks ago, the Washington Post published the story where a Google engineer claimed that one of the models that were being developed inside Google was demonstrating sentience. So it was demonstrating the capability of being sentient and probably being alive. So this was big news at the time. And obviously it's always interesting to us when we hear about machines that are becoming self-aware and becoming sentient. That's always been the holy grail for computer science, to be able to develop sentience and self-aware machines. So first off, I should say that there's a lot of hype around this news. What actually happened was Google has developed a neural network model, an artificial intelligence model that they've called LaMDA, which stands for Language Models for Dialogue Applications. Now, this falls into a class of models that are known as large language models. And these are neural network models that are trained on large amounts of data, text data mainly, in order to do language tasks, things like language understanding very well. So in that sense, LaMDA itself is a huge step forward, because language models today are getting very capable, and in terms of being able to mimic language abilities, human level language abilities, for a host of problems, from things like for dialogue agents, for question answering, for intent understanding. But this claim of sentience is a little premature, and it's a little hype right at this point. That was the opinion of one of the engineers who was testing out this system, and in fact, so we don't have access to the LaMDA system, but I think the consensus of a number of AI researchers around the world is that this claim is premature. In fact, what happened is LaMDA is trained to produce answers to questions in a very convincing manner. So the way it works is that, given some text, it tries to predict what the subsequent text will be, either the subsequent word or the subsequent few words. And it does this very well because it's trained on a large amount of text data, huge trillions and trillions of words. So in effect, it's kind of seen almost, all sorts of combinations of words that are possible. So when you ask it a question, it tries to complete that by predicting what the next text would be. So in that sense, it does not have sentience. Rather, it's just doing what it was trained to do very well. So the more pertinent question here should be, is it mimicking the personality of the data that it is trained on? So is LaMDA, or is the model mimicking? If it's mimicking anything, it's actually mimicking the data that it has been trained on. So like I said, large language models like LaMDA, there's another one called GPT-3, by another organization. These work by ingesting huge volumes of data and then trying to learn the underlying patterns in that data. The patterns of what word follows, what. So what follows what. If I present you with a bunch of words like, a simple example like the cat sat on the blank. That blank can be filled in with a number of words, and one common word to fill in there would be mat. The cat sat on the mat, right? So in a very very naive basic sense, that's what a model like LaMDA is doing. Obviously, it's doing more complex things because it's trained on a lot more data. It's able to fill in a lot more words. You can give it a prompt, and it can go on and write an essay for you and things like that. So while human-coded heuristics, while rules can be at some stage introduced into the output of LaMDA at a very basic extent, very basic level, it's just trying to predict what the next words would be. So this is similar, in some sense, to another example that happened. Another bot that was developed a few years ago in 2016. Microsoft developed a chatbot that they call Tay, which was again designed to do the same thing, right? So it would look at examples of text and try to kind of mimic those examples of text. Well, to a certain extent, you can consider these two models to be similar, right? Similar in the sense that both LaMDA as well as Tay, they're designed to learn from the data that they're presented with or the data that they are exposed to. LaMDA is just a lot more recent, so it's a lot more sophisticated, both in terms of the underlying neural network architecture or the algorithm that's used to power this model, as well as the amount of data that was used. So the amount of data that was used to train this model is very large, and it's LaMDA is referred to as an open domain model, right? It can converse, or it can its language abilities span a number of domains. So, for some time now, machine learning and artificial intelligence models, the algorithms, the models themselves, the architectures of the neural networks, these are, all pretty much freely available, right? I mean, they're published, they're freely accessible. Anyone can build these out, once they're available. Also, of late, the data that's used to train all of these models are tending to be, less effort data. So you don't need a lot of effort in terms of human effort, in terms of annotations, in terms of tagging, in order to prepare the data sets that are needed for models like this. You need clean data, right? But you can get away with using lots of data as opposed to well annotated or what we call high effort data, right? So in that sense, there's a big temptation, to take the sophisticated models, to take a lot of data, mix the two together and use that to power a lot of applications. But with that arises the problems of bias in data, right? If you just blindly apply data and apply a model on some data without understanding are there biases in the data itself, those biases get kind of learned by the model. This is a big problem. So what we've been talking about so far, in terms with respect to LaMDA, are deeper problems, more far-reaching problems with AI. Problems like people getting confused about whether an AI system actually has sentience or not. People trusting implicitly the outputs of their AI models. So for instance, what if you had an AI system that was generating the news for you, right? Should you trust all of the news that's coming out of that model? But there are more present day problems, more problems related to the way businesses are run today. So for instance, in the financial world, a bunch of fintech companies that are using models in order to do things like loan approval classification, right? Should I approve a loan or not? What should be the credit limit that I can award someone when they apply for a credit limit raise? And there are documented cases, right, today of a lot of bias, human bias, that has crept into the models and the outputs of those models. And you have problems with, for instance, if a man and a woman were to apply for a credit card increase, credit limit increase, everything else being equal, there are cases where the man has gotten the higher limit, again, as opposed to the woman. You'd also, have problems, again, documented cases of image classification gone wrong, where humans of certain skin color were classified as apes as opposed to humans of another skin color. You have problems in the healthcare domain where the patients are not provided the same diagnosis or the same treatment regimens just based on their medical history, right? We have to be very careful of when we allow machine learning and AI to make these decisions for us. Right at the beginning, I think it's important that any practitioner or any machine learning AI developer is aware of the fact that biases will creep in, right? And these biases creep in both as a function of the model itself, but more because of the data that's being fed into the model, right? So machine learning and AI depend heavily on the data that goes into training these models, and any biases, any contextual deficiencies get amplified when they are learnt by the model. So this is not only a concern for your big ML and your huge AI systems, but also for sub-ML, for small everyday ML systems as well. I think it's important that developers need tools that allow them to examine the data that's being used, that's being fed into their AI systems, that's being fed into their models, statistical models all the way to the things like these large language models. Machine learning and AI relies heavily on transformed data, right? Because data goes through a number of stages, right? From ingestion or from the input all the way to when it's actually being used in a model. And through that process, there are a number of transformations that happen. So to be able to look at the data at every step in between is very important. So these tools should include things like the checkpointing of the data frame at each step in the transform, the ability to profile your generated features, to be able to look at distributions, the ability to look at drift and to be alerted when there is drift in your underlying data, right? So you're expecting something, but the data that's been trained today, or the data set that's been generated today is different from what you're expecting. These are more than looking at the machine learning models and the algorithms themselves. Looking at the data is more important for a data practitioner, any data practitioner.